All right, should be live. And I'm back finally to look at that TTY thing. So I had an idea. For those who missed it, when I was traveling earlier, I ran into a really strange race condition, I guess, that I am now quite convinced is a problem in the Linux TTY layer. Probably one of those things that only happens on M1s. But it also only happens on the Arch Linux build of the kernel that I'm using. It doesn't happen in the like my testing kernel builds, which are usually a bit different. So one thing that that I thought of doing originally is just like bisecting the configs and trying to figure out what's different between them. But I had a better idea. I have a weird testing setup that I've come up with. And I'm just going to use the regular kernel that we ship, which does reproduce the problem as the base, and just try to like fix the problem, like debug and fix the problem. So here's what I have. I actually just installed Asahi on my Mac Studio because I didn't even have it properly installed yet, and that's going to be the guinea pig machine. Then I have the Mac Mini under it. That's the target, because this is a problem that I can trigger by communicating to Mini on a, on a target machine. And I have the Mac Mini hooked up to my like weird Arduino cable thing that I usually use. And the reason for that is that Mini does not support USB hot plugging, but actually it does. What it doesn't support is USB hot plugging with a VBus power cycle. If you drop the 5 volts from the USB port, the USB controller will reset. Mini does not support fixing that and doing the right dance to make all that work again. However, you can actually disconnect the data lines and reconnect, and that will attach and reattach USB no problem. So by doing this, because the 5 volts is not provided by the actual USB cable coming out of this Arduino contraption, that means that I can actually reboot the Mac Studio to test different kernels without having to also reboot the Mac Mini to get Mini to work again. And that's so that helps out. And then the M1 Pro laptop is going to be my host machine, because that's actually where I do my kernel builds anyway. So if I can reproduce this with the kernel in the Mac Studio, which I can, then I should be able to just keep building kernels here and test them from this machine, and it has all the tooling I need installed anyway. So that's the funny plan. So yeah, I just spent some time setting that up because it was a little bit painful. What priority does battery life have? I mean, it depends on what you call priority. Like, battery life is a function of many different factors. But I mean, you already get like 16 hours of screen off time, so I don't think most people are worried about battery life. If you mean like efficiency, that's, where things like the GPU come in. But I'm actually going to be working on power management after this anyway. Because I'm going to get sleep mode to work, mostly so that people are like confident sticking their laptops in bags, not because you actually need sleep mode for the machine to last a while. So let's see. So yes, I have. So for the record, Mastery is my laptop. That's the host. That's the top level. Okay, I have 4 machines here. Okay, so this is confusing. I have my development machine. That's Raider. Mastery is my first one in the chain of M1s. Then I have Yell. That's the Mac Studio. That's the second one in the chain. And then, well, the host name doesn't matter, but I have Fua, which is the Mac Mini. That's the third one in the chain. So I'm chaining 4 machines here. What could possibly go wrong? Why aren't I helping with the GPU driver? I mean, I have a lot of things to do, and someone else is working on the GPU driver, right? Like my job in the project is to do what nobody else is doing. So I pick up all the bits and pieces that nobody's working on. And that's why I'm fixing this TTY issue. That's why the next thing I'm looking at is the firmware for the USB ports, and then the Wi-Fi coexistence and sleep mode. Those are all things that nobody else is doing, so I'm doing them. Okay. So let's get in here. So I have my usual secondary terminal loop, but now it's from Machery, so I'm like SSHing in. And now that's already, the Mac Studio is already in mini override mode. For those who don't know, you can turn off SIP in recovery mode and get it to give you a timeout on boot. So as long as you have like a loop like this running, it'll always break boot and give you a mini interface. And so now I should be able to just boot my usual kernel. And now I'm thinking that since I'm messing with a TTY layer, hopefully everything that I'm messing with is going to be internal, like to the core part of the core kernel image. So I don't actually have to like install modules or anything. So let's try first a regular kernel boot. Mini proxy client tools linux.py. Oh wait, I need to grab the init ramfs. But I can probably just use the one from this machine anyway, because it should be the same as long as I'm updated. Let me make sure I am. Yeah, I am. So yeah, I can probably just use the binaries from this machine. Should be basically the same. Yeah, the wiki page is a good starting point, but it needs to be updated because there's more yaks in need of shaving than those that are listed there. Has any of the work I've been doing last week been pushed to the mainline kernel? I mean, there's a lot of things that haven't been pushed. All the MTP stuff isn't pushed yet, and hasn't even been submitted yet. Upstreaming things takes time, and the thing is, you don't actually want to submit things too early until you're confident about the approach you're taking. So I have a backlog of things I need to submit, which I'll probably do in the coming weeks because it's a bit overdue on that. But it also does make sense not to submit things for upstreaming like right after they're done, in theory, because you might decide that the way they've been done is not the right way after that. So okay, this should be fine. And Python tools, linux.py, run myself of this. I don't think we need any boot arguments. So just well, let's use the actual build for now. Boot VM Linux Asahi. The DTB should be lib modules Asahi DTBs, and this is the Mac Studio, which is J365D. That should, and then init ramfs boot. Just grab this one. That should get me a booting Mac Studio, and that'll kill the terminal. And hopefully I get Ethernet and everything, and it should reproduce the problem. So let me do that. Oh, unknown compression. Oh, is it? These aren't gzipped? Yeah, they are. Oh, is it just guessing by like the file name? Yeah, okay, it just needs that. Gzeb. Oh, okay. I guess those can have secrets in them or something. I'll just copy this. Oh. Yeah, that's normal. And now if I do that, hopefully that will work. Oh, that did not work. Oh, I think I do need to pass the root. Yeah, I do need to pass the root file system, of course. Let me just reboot that by hand. And this is a fresh install, so I should be able to just pass root equals. What are the command lines for this anyway? Yeah, you get the, yeah, you actually need to pass the root. So let's do that. Is that root file system actually what I want. NVMe 0 and 1P5. Should be one. Is this a fresh install? So once recovery 2 is Mac OS 3 and 4. Yeah, it should be 5. I might as well run in debug mode. Yeah, okay, that's booting now. Well, that stream buffer really is slowing things down. Okay, there we go. So that's fine. And now I can show you... yeah, there we go. So let me show you the problem. Asahi git mini proxy client python experiments reader.py. If this doesn't work, I'm gonna get annoyed. Yes, it fails. See, it gets stuck there. A random point. I can kill it and do it again. It still works. Fails at a random point, but very consistently within like 1 second. All this is doing is reading memory from the Mac Mini. That's all it's doing. But because of the way the USB packets end up split, it triggers the problem. So let's... So thankfully, because I'm not rebooting the host, I can just SSHFS into that and use a real editor. So let's do that. Asahi mntfs. Oh, I don't have a mastery there. So I'm going to reboot this. And then we're going to try it first on the hypervisor. See if it's reproducible with that. So Python tools. I have a script for that actually. It's called tools. Oh, wait, that isn't pushed? Oh, script, sorry. Utils? Okay, I'm forgetting where I'm... What is this? July? Did I, like, not push main or something? Oh, wait, this is Mashari. Yeah, Mashari hasn't been updated in a while. Were these not pushed? I might not have pushed these changes yet. Yeah, I should push those then. Minor things anyway. I think those were changes I made while trying to debug this and then realizing it wasn't actually Mini's fault. So Python, not Python, tools, run guest kernel, that one. So tools, run guest kernel, this needs, oh yeah, it needs a kernel build root. That's not actually what I want. I have to do this by hand. I do have to build Mini. And yeah, I'll do this by hand. xHCI. So I can just do cat build mini bin, and then we need the DTB, the init ramfs, the kernel. Boot args needs to go in here somewhere. I keep forgetting if this is boot. Boot args. Yeah. Boot args equals what I had before. Something like that. Have coordinated with the kernel team and the TTY there. I'm fixing a bug. I don't need to coordinate with anyone to fix a bug. It's broken. They're not going to deny a bug fix. Okay, so let's try it chain though, just to make triple sure that this actually works first. -b -r. Oh, right. This still wants I should fix that so it actually works on native. Why haven't I fixed that yet? How do I find out what the current document name dash what? Dash m. Yeah. Just fix that. It's mini asm. Sorry, mini asm py. Actually, is that? Yeah. Yeah, let's make it native. I should also just make the make file do that, to be honest. View name Darwin. View name parm. And dash p, was it? M, sorry. And then I can just grab that. Oh, this has a mouse integration. I should just turn that off. In Vim. Do that. Rust Arch probably still needs to be like that. Let's just try that again. Yeah, it works now. Yay. Makes life a bit easier. So let's try the chain load again. Oh, that didn't work. Did I break that? Oh, wait. Self arch. Oh, yeah. Well, that's dumb. I think I added that at some point to make that work and then forgot to change the default arch thing. Okay, let's try that again. There we go. It's not going to reconnect. Is it booting? Yes, it is. Slowly. Asahi git mini experiments reader.p proxy client. So. Okay, it does repro. That's good. Now let's try the hypervisor. Which means just doing run guest on this. Which does support raw binaries these days, I think. Yes. That got added by someone. I don't need any. Yeah, I don't need anything. I do need to chain load, probably. py.speed, just to make sure it's the same build. Actually, it should be compatible because I haven't changed anything here, and I literally just installed this with the latest build. So this is one of the rare cases where I'm confident I don't need to chain load again to... Wait, am I? No, that is the... No, sorry, that's the built-in mini, not the one that is installed at second stage. I do need tools chain load py-b build mini.bin and run guest. Am I using the M1 M2 for dev now? Well, right now I have 4 machines involved, 3 of which are M1s and one which is an Intel, which is the one I'm like actually running this UI on, but so I'm not sure how to answer that question anymore, given the strange thing I'm doing today. So let's let's run that. Let's see if I get oh, and there's R. That did. Oh yeah, right. It takes a while to initialize because this one has like a ton of USB ports. It's slower than usual. Okay, it boots. Way too many CPUs because this is a Mac Studio. I should also turn on the login, but actually it doesn't really matter. Okay, let's run it from here. Okay, it fails. Good, good. The hypervisor makes my life a lot easier. So, now let me try, see if I can literally just, cat. I don't know if this works with the init ramfs, but I think it should. So I can probably just do, oh, did I mark that executable? I don't know if I marked that executable. Let me just run it again to make sure I'm not dumb. Oh, did I just chain load? Yeah, sorry, that's fine. And just make triple check that that is actually marked executable. It isn't. So it needs to be marked executable. And it should just work if I run it. Asahi. Oh. Oh, it doesn't have shebang. Hey, it works. Okay. Let's just do a clean reboot, make sure it flushes that. So now, I should, let's see if I can just make it init equals home markan Asahi get mini proxy client experiments reader.py. Who runs Python scripts as their init on Linux? Let's try that. That did not work. Oh, because dev mini doesn't exist. Yes, I'm gonna need some kind of Udev thing. I don't have Udev. Okay, let me make a little script for that. See if I can just have something to bootstrap it. I can just have something to bootstrap it without like Udev and everything. I don't really need mounts for this. I mean, the root is going to be there. I do need Udev though. Oh, I don't really need Udev. What I really need is just the module loaded. Really, I do have the normal init RD that is getting loaded. It's just the Udev rule for that isn't applied. So I don't know if I'm just going to do a bin sh actually. Yeah, let's just do a bin sh, see what happens. And then I can see how much I need to do. And this is using the normal init RD, just, you know, skipping the next thing. I mean, I could also just make a unit to run it on boot and stuff, but it's just, if I can do it this way, it's a bit easier. So give me a shell. There we go. There's my shell. And now, ACM, no. So the dev does have, yeah. So I think I just need to do that. Yes, that's all I need. I just need the mod prod CC ACM, and then I can use TTY ACM1. That's it. That's all there is to it. So then I can do or can Asahi git mini proxy client experiments reader.py. Ooh, that took longer than usual, but it worked. Oh, and of course I know no job control here. Oops. Okay, let me just make a script for that real quick. Let's just make sure this is remounted read only. Vim root test.sh. Sleep 1 second. Okay, let's give that a shot. Did I chmod it? Yes, I did. It's possible it needs more sleep depending on how the USB enumeration happens, but let's see what happens. I think it worked. No? Could not open port. Maybe the USBs didn't probe yet. I think the USBs just didn't probe yet. Probably needs more sleep. Let's do a quick count now from how long it takes from the Yeah, I could check with the while loop, yeah. Might be a good idea. I'm curious though how long it takes. Let's see. Let's take a look at it. So it's gonna be I think it was like 1 second only from the shell to the device showing up. Yeah, that does work. Yeah, I think it should work. Let's try that. Root test. That looks like it got stuck there. That's kind of weird. It's like for some reason it's not probing. I think it loaded, but no, it's not. It's the USB isn't probing, but it was probing. And it's like starting to probe. But why would it work with binsh and not this? That doesn't make any sense. What happened during the... Or is it just like a race with the boot time Udev doing something different? But it's just... Or am I just unlucky and it works sometimes? And obviously the TWC driver actually started probing. Maybe it's just a fluke. Maybe it's just random. It works sometimes and not the others. Like, I don't get why using a shell as init would change that kind of thing. I mean the demessage. Oh no, now it worked. No, it worked. Yes. Okay, so yeah, it's just random. It has nothing to do with the shell. It's just I think I need to load more modules probably. I think it just depends on whether the init ramifest picks up on some things or doesn't. Yeah, it's just depending on whether it picks up all the modules or not before the root file system. Yeah, so as long as I load all the modules I need, and it'll work, which is not going to be too hard. Just need a big pile of mod probes. Yeah, I mean, I could just run Udev, let it do the work. But whatever. I mean, now it works, and I know all the modules, so just trim down this list a bit. I need that. I don't need that. I don't need that. I don't need that. Actually, I might... No, it shouldn't need that. I don't need that. I don't need that. I do need that. I do need that. I don't need that. I don't need any of those, I think. That one is definitely going to be loaded. PCIe I don't care about. xHCI I do need. SPM I don't care about. Pin control I do need. I don't need the Mac SMC RTC. I do need that. I do need that. And I do need that. So yeah. Vim root test.sh. Oh, and CCACM, of course. Wait, why is it working? No, it doesn't. Okay, so sometimes it just takes a while, which is interesting. Okay, I think that should work. Can I reiterate what the issues with the TTYs? I mean, I don't know if it happens on other machines. It probably does. I just happen to have stumbled upon it on M1 Pro. But as you can see, it just hangs sometimes. And what I got so far is that the TTY ACM driver pushes data to the TTY, and then Linux gets stuck and doesn't get that data. But that data arrives the next time the device pushes some data. So something about the TTY layer receiving buffers and pushing those buffers into the other side is racy. And that's as far as I got. It took me a while to get there because I thought it was a bug in my code for very long. I know that you can work around it in the CDC driver by doing a memory barrier and calling the push twice, so it really does sound like a race condition. And I took a quick look at the TTY code, and there is like a pile of atomic magic at some point in there. So I have a strong suspicion that that code is broken in some way that only reproduces on M1 machines, which is very likely because these machines are so wide and has such a wide reorder buffer that they find bugs that no other machines do. Not the first time. So actually, give me 1 second. Just gonna grab some water. Be right back. Oh wait, you have the same bug on Mibcell? Am I not the only person who has seen this? The TTY ones, really? Okay, that's interesting. Wait, kernel to spin? This is not spinning though. What happens here is that the Python just doesn't see the data. Like it'll run select, and select will not return poll in. So it's just as if the data isn't there, even though it is in the buffers, and it gets pushed the next time around. So it's not actually a deadlock in the kernel or a spin lock in the kernel. It's just the data is in limbo, and the other side doesn't see it. Yeah, so with 2 pushes, it gets fixed. Well, that's interesting. Good to see that I'm not the only one. And that it reproduces on another architecture, which is supports the idea that this is a race that only reproduces on some machines. Okay, so now let me open up another terminal to do my kernel builds. So the next thing I need to do is make sure that this build that's in here, and this should be 5.19.3, which I just compiled yesterday, that I can actually do another build here and it's not going to break anything. Let me make sure I run exactly the same make command. It's just make all. Okay, good. So hopefully this will give me a kernel that also fails. That is slow. Is it just because it's doing a lot of things not parallelized? Because this machine is fast as doing kernel builds, so yeah, I think it was just... Okay, so the magic incantation here is going to be make-c and -j10-c, all of that, and cat build mini modules DTV. Yeah, DTV I can grab for that, but the image I need from there, and not the init manifest, the kernel. And then I can run the hypervisor all in the same command. So we end up with a giant thing here. That sounds about right. Okay, let's make sure that repros. And while that happens, I'm going to pull up these files from the mount. Asahi, git package builds. So this isn't even a git repo, so actually git package builds, Linux Asahi source. So I'll have to like diff this later. Which might make it a good idea to make ourselves an org. That's slow. Oh, I'm in bin sh here. Sorry. Why is it so slow? What the hell? This machine is supposed to be a lot faster than that. Oh, because I'm on SSHFS. Yeah, duh. It's straight from here. Yeah, duh. Six months ERC one's been released yesterday. Yeah, we'll do a release on that probably after this is fixed and some other stuff goes in while I'm on that. Init root test.sh. We can run another test. Oh, finished. Okay, good. So let's grab that. And now the TTY stuff. Kernel, actually, drivers, TTY, I think is what this is. Yeah. So yeah, this is going to be interesting. Yeah, repros. Okay, cool. And while I'm at it, I'm going to also... I'm going to make this chain load as soon as the hypervisor exits and save myself some time, because I'm probably going to exit it before booting something else anyway. So let me just do that once now. Just kind of interleave things a bit. That should be fine. Okay, so I can't edit the CDC driver from here because that's not that's a module, but I can at least show you. Yeah, so this is the issue, right? It takes a lock, inserts flip string, then does a buffer push. If I do this twice with a memory barrier in between, I don't know if the barrier is required, but it was just a hunch, then it works. So whatever TTY flip buffer push is doing, there's a race there. Where am I in USB here? Up there. I can leave the command in history. I like to leave a lot of long things in history like this, so it's not a big deal. So TTY flip buffer push, where is that? It's in here. And what that does is TTY flip buffer commit, and then commits the work to the work queue. No, it's not the spin lock because this function cannot get called multiple times because that wouldn't make any sense. If multiple USB packets triggered overlapping callbacks, you wouldn't have ordering guarantees. So it's not actually a locking issue here, as far as I can tell. It's just that something in here has its own race condition with the other side. So look, SMP store release, right? Like we already have like memory ordering stuff. So in theory, the only thing this is doing is that SMC store release and then queuing work. So that's one obvious fix. Also, why is my tab size ridiculous? I need to copy my kit config to here, but also why is right now the default? Oh, it is 4. Is there a crazy kit config somewhere here? Hold on, let me just copy that from somewhere because yeah. That's better. Okay, let's try that, which is a very obvious fix. And that'll, almost certainly tell us that the problem is that store release not being correctly paired with something. I'm very happy that the hypervisor does not make this not reproduce. Makes life a lot easier. Do I ever feel like the work ahead is insurmountable? How do I always keep pushing forward? See, the thing is, it's a computer, right? By definition, you can make it do what you want. So what, like, it's technically possible because it has to be, right? So then it's more of a question of how much time it takes. And I mean, we have a pretty good team. I'm very lucky to be getting funding for this, so I can actually work on it as, my primary source of income, not just some side job. And, we're making pretty good progress already. So it's kind of hard to fall into that, right? Look, it works. Well, that's for starters, that's a less insane fix than the thing I had before. So that's a very, very good start. Who uses store release, load acquire? So wait a second. Does store release even make sense there? Store releases have to happen. Oh yeah, no, that's okay. That's wrong. That's already wrong because a store release can be moved after anything before it, which means it can be moved after the work queue, which means and ARM does not guarantee acquire and release is not. Isn't this the same thing? Oh god, hold on, let me open up the ARM doc. I have a feeling I know what this is. I talked to the ARM guy about this, but in a different context in the kernel, this is the same mistake is made, I think. And I have and I have or maybe it is that problem. Oh, it's gonna be so fun if it is that. Hold on. Ooh. But if it is what I think it is, then it's not the MIPS problem because the MIPS has a different issue because this is architecture dependent code. Yeah. So hold on. SMP store release. Which compiles to what exactly? I need. Let's go in here. Object dump the. The thing is, though, we still don't know exactly why this happens because at least IPIs I know are supposed to synchronize. I do believe we get that right in the interrupt controller. However, I don't think this necessarily involves an IPI because if the other end is already processing that work queue, then it might just continue anyway. So maybe it's like a misunderstanding as to how qwork is, what guarantees qwork is supposed to have. But first, let me make sure that I know what instruction that's actually uses. Yeah, it's STLR, and that's my memory barrier there. So the STLR is a store release. Yeah. So let me find the where I talked about this. Is it STLR? There's something about atomics. Search all inboxes. Because I sent an email about this at some point. Yes, this one. But I was talking specifically about atomics. These are different, and I even have a litmus test here that proves the problem. Specifically, yes. Yep, load acquire and prior memory operations and storage and such sequence. Yeah, exactly. So yeah, acquire release fully ordered. That's not fully ordered because you can still go through. Yeah, so it's related to that issue, but not exactly the same thing because this is for because that was for atomics. However, it can still be that. So first, let's see about SMP store release and what the docs for that says. Yep. So that is clearly documented. That's the reason if you're happy for completes, yes. So, this frames with paired with acquire and flush dual disk, ensures and this sees buffer data. I'm not sure that actually makes sense. Hold on. Where is flush dual disk? What happens if I don't use it there? What do you mean? The barrier? If I don't, but the bug happens, right? Yeah, called out of the software interrupt to flush data from the buffers into the line discipline receiver for instance, there's TTY instance. So that locks the mutex. No guarantees there. Then there's a load acquire on next. A load acquire on commit. Yeah, no, sorry, that's not how this works. That's the bug. There's a while one here, so this is not even guaranteed to happen due to that work queue. It could be the next packet comes in, this runs again, sees the old data. If need, reshed, con reshed, unlocks the buffer. And there's only guarantees that that's going to run again after that, but I don't... So the question is, commit read head, if next no break, okay, continue, if not count. What does TTY buffer free do? That's free TTY. Yeah, I literally freeze the whole buffer. There's a flush. There's a load acquire. Okay, let's get a flush to L disk. Tail used. Tail commit. So how does this make sure the count is commit minus read? So if there's nothing left, if next is null, then break. Otherwise, buff head is next. It's port buff tail is what we're seeing there, and then port buff head. This is port buff, sorry. Buff head. So it looks for it grabs the head of the buffers. And then it I don't understand this TTY buffer free. Oh, if next is null. Okay, so if there's no next buffer, that means this one is not going to get written anymore. So if it's null, then it just breaks. Yeah. So this is just going to return if that... Yeah, so basically, then this comes down to whether this qwork is going to guarantee memory barrier semantics or not. So this might not actually be a TTY bug. It might be a deeper bug in the kernel. Because I would expect qwork to guarantee memory ordering. Because otherwise a lot of things would break. Which could be that the bug is in our interrupt controller code, but well, let's try that. Okay, so let's look at drivers, RQ chip, Apple AIC, because I don't know if this is ending up on an IPI at the end of the day. So in theory, let's... Yeah, Comex says that guarantees that all stores receiving the call to qwork. What about the return true part? Where's the actual docs? Not that. Returns false if work was already on a queue. See, the thing is, work might already be on a queue. How, we queue the work to the CPU on which it was submitted, but if the CPU dies, it can be processed by another CPU. That's also weird because... No, it isn't. Yeah, so then it's probably not even going through an IPI. Okay, let's just try that, just to make sure. IPI send fast. I'm just gonna put a memory barrier here. Actually, even just an ISB should do it before that. And let's do both, actually. And no barrier there. Try that. And then that exonerates my driver, I think. Though I would still need to do it with the atomics. Let's try that first and see what happens. And then I guess I need to look at qwork and see what barriers it's using. It might be the wrong one. Okay, that still crashes. So not this at least. Just to make sure. Yeah, so this is there's an unmask and send mask is what I want. So this is where all that magic happens. So if I put these in here and it still doesn't fix it, I think I can say it's not my fault. Oh, you solved part of your issue? I swear, if this isn't even a TTY thing, it's like memory work queues in the kernel are broken with ordering guarantees. Or if it's because it's using those if it's hitting that race that I sent on the list, and by the way, that's not fixed yet. This isn't fixed yet, and the reason why it's not fixed yet is because Will thinks no actual existing CPU takes advantage of this. Maybe the M1 does. Okay, it still crashes. I'm pretty sure it's not my fault. I'm gonna leave those barriers in just to make sure. But if the workqueue stuff somehow uses atomics, ooh, that's gonna be fun. But yeah, clearly this is getting reordered after the work running on the same CPU. So that's gonna be interesting. I'm gonna tweet that. 1 sec. All right. So how does qwork actually enforce that ordering? Oh wait, hold on. This doesn't even make sense to hit if it's on the same CPU, because of course those read writes would be visible from the same CPU. So that means this is running on another CPU. Oh wait, well no, it could be preemption. No, but still, that doesn't make sense. Unless it just isn't returning true. Can you queue the same work on the work queue more than once? Yeah. Okay, what is this one? Oh, well, that is unbound. Not bound to any specific CPU, not currently managed. Yeah, so that does sound like it's going to run on any random CPU. I think that thing about the I get the feeling that we queue the work on the CPU and it would just submitted is probably not actually true. Yeah, so that's probably only true if you don't set the unbound flag. So it is going to run on a random CPU. But I mean, if returning false means it didn't queue the work, then this isn't even this race. Then it's just not even getting queued. Let me just print, because then obviously that's broken. If that ever prints, this is broken because of TTY. Because obviously, if the existing code is running and that causes it not to queue again, there's no guarantee that the code is actually going to finish, and like the loop is going to catch that last push. So yeah, if it's false, it doesn't get queued, right? So I think that only happens if the work queue is full or something. No, queue the work or ensure it's already queued. Queued but hasn't started running makes sense. Is running does not. Ooh. Okay. Let me actually print the flash to L disk. Because if by the time it fails to queue, this is already running, and I need to make sure the ordering here is right, so just do print queue. Yeah, it spewed a bunch of false. And so if the semantics is that it only returns false if the work was queued but not running, that's valid except for the memory ordering problem. And then the API just sucks. If it was actually running, that doesn't make any sense. Because if you're trying to queue the work to actually run, then like the way the TTY layer is using this API is completely broken. See, this might actually work this time because of all the print case causing ordering. I'll let it run for a while though. But there's some failed to queues in there. See if I get lucky and it dies. Might not though. But at least I can see if there's any cases where it's obviously doing the wrong thing. So let's look at one of those failed to queues. Okay, that looks fine because it tries to queue. It's already running, but then it fails to queue, and then it's running that anyway. As long as we don't get a not that after the failed to queue. Then I think it's fine. So I think, yeah, the problem is just that the ordering. Yeah, then that API is just terrible. No, the thing is, failed to queue means that work is already in the queue, which I guess means. Oh, let me just read this a little bit. Yeah, same queue, does not break those conditions. So yeah, I think the idea is that if a queue is already, if it's already executing, then um yeah. So according to the documentation, this is fine. It's just it doesn't guarantee ordering in that case. So how does that implementation work? Let's take a look at that. Asahi Linux. Is it in kernel? Might be in here. Yeah. Kernel workqueue.c. Let's just open it up here. What's the actual entry point for that? Is that just in a header file? Yeah. Okay, that's just qwork on unbound. And that just does work struct pending bit. Okay, that is... Yeah, if it's already pending, it just doesn't guarantee any ordering. Well, that's lovely. Is there even a proper way of fixing that? Yeah, so there's an atomic test and set bit. And we need to create ordering there. Let me undo the debugs here, because obviously that doesn't help. Failed to queue is fine. Yeah, so any ordering, if we want to do this sanely, other than just throwing a barrier, because this API is working as intended, but the way it's intended is stupid. Because it doesn't make any sense. Because normally what the TTY layer is doing here is sane, right? It's saying I need to run this function after whatever I just did. If it's already queued, that's fine. It has to run once, but you need memory ordering there, otherwise it doesn't work. And if it's creating memory ordering when it queues it, it also has to create memory ordering when it doesn't queue it. Otherwise, what's the point, right? No, if the thing is, if the item is already, I saw it with the prints, right? If the item is already queued, it's not running yet. It's just queued. So as long as we can create ordering between this test of whether the data is queued and whatever clears that bit on the work before running it, that will create the required memory ordering. It's this bit is the memory ordering point we need to use. Yeah, it needs to be released, but where's the acquire that needs to be acquired on the other end? And probably a lot of these have to be released. Where does this actually run? Clear work. Clear bit. Inactive bit. Active. Pending bit. Process one work. Okay, but that doesn't that just reads it. What writes it? Yeah, that might be interesting. There's this documentation. Core API workqueue blame Wait. Oh, it's just kernel doc. Oh, look, this is reasonably recent. Yep, it was just documented. Neat and also not useful. So how does this get reset? If it does. Oh, does this reset it? Hold on. Work data, work queue, work color. Now it's just work color. What sets that? Is that in the header file by any chance? No, it's just test bit. See you later. Konnichiwa. Work extract. Hold on, where was I? Pending bit. Okay, so where does the work get processed? Worker thread, okay. Do. Session generating on what data bits, extract linked. Process scheduled works. Okay, let's just trace this. Process one work. Process one work. It does read the bits. It doesn't list Dell entry. Set work on clear pending. Okay. Set work data. Okay, it just does everything. So that's the... and look. So there is a write memory barrier. Implied memory barrier in test and set bit pending? Oh, I don't think so. So someone tried to make this work and failed. Yeah, no, I don't think so. We found the magic comment down here. Now I'm gonna spend another week, like this Apple AC stuff. I spent like 2 weeks agonizing over memory ordering to make sure this was kosher. So now I'm gonna have to spend like another week. No, hopefully it won't be that bad. Okay. Where is the other side? Let me look at them side by side. Pending. Where was I? The qwork on, yes. Qwork on, test and set bit, yes. Okay, so here is the magic screw up. What do they claim? The following MB guarantees that the previous clear of a pending bit will not be reordered with respect to any speculative loads and stores from work current func which is executed afterwards. 10 clear pending, clear bit. Well, this is about missed executions. There's a store in line 1. Yeah, so it's the same problem. And the new execution works is not queued and hope that they'll eventually finish the queued work. Yeah, this is exact. Okay, someone thought they knew what they were doing, and something is wrong. So write memory barrier. What is the docs for that? Okay, make sure you get the docs for that. It's not DMA, it's just write memory barrier. Okay. So that just means it's not going to be reordered on the right side. That's fine, but then we need a read memory barrier on the other side, which we don't have. Implied MB in test and set bit. I'm not so sure that's implied anywhere. Oh, it claims it implies a memory barrier. Interesting. I betcha it doesn't on ARM64. What is that getting compiled to? That's gonna be another tweet if where is that? Test and set bit. Oh, the wrong include maybe. Where is this implemented for ARM64? Let me just dump it. Kernel workqueue O. LD set L. I don't think that's a memory barrier. Yeah, it's just it's release semantics. It does not imply a barrier. This claims it implies a barrier. It does not a full one. Well, there we go. Let me just tweet that right now. Yes, release semantics in theory what I need for this specific case, but that's not what the API documents. So if we want to use release semantics here, that's fine. But right now, test and set bit is broken. Where is that implemented? I'm going to send that patch right now, because that's going to be a lot of fun. No, it does explain the failure because we don't have acquire semantics on the other side. Yes, the release semantic is fine, but we're not doing acquire semantics on the... Actually, it doesn't even make sense. We need release semantics? No. Release semantics is not what I need. What I need is acquire semantics. Because this needs to always order after that. So I need... Sorry, let me think about that again. It's not release semantics. That doesn't work because that can always be moved afterwards. So that's not enough. It would need to be acquire semantics with the set work data. So the acquire can never remove the head. No, sorry. Now I'm confusing myself. Neither works. Neither acquire nor release semantics works. That's actually the same confusion that was related to that email I sent. Acquire and release semantics are used to make sure that a block of memory accesses like does not overlap with itself. It cannot be used to make sure that two different blocks of memory accesses don't overlap with themselves, because then you'd need like acquire and release on both ends. Like you'd need like an acquire before there's a release. You need a release semantics here, then an acquire here. Yeah, no, sorry, acquire here would work, but this is not acquire. Because a write memory barrier is not an acquire barrier. Because it's not a read barrier. This doesn't matter. This barrier doesn't matter because by the time it gets here, it... Hold on. Let me think about this again. This only guarantees that the flag is cleared before everything else runs. The question is, reasoning about memory ordering is so annoying. Let me think about this. First, what does actually acquire semantics read? Yeah, the acquire only creates memory ordering with the accesses after the acquire, not anything before that, which is what you want. So the CPU is perfectly allowed to run this earlier, and then it doesn't matter what this CPU is doing. And then after that, commit this stuff. And none of this matters, because this CPU didn't run the right barriers. So yes, this is broken. The CPU is allowed to move the buffer push to after this acquire, because that's how acquire works. And no, it doesn't matter how many barriers you put on this side. It's not going to help. Yeah, but acquire release is only about what happens after, not before, right? This is an acquire, which means it's creating ordering between this line and what happens afterwards. But what we need to create order is between this line and what happens before. Acquire doesn't do that. There's no release here, it's just acquire. Test and set bit is just doing an acquire. Look, it's just LD set al. No, it's not. Sorry, it's just a release. Sorry, I'm confused. That was a release semantics. Okay, hold on. Sorry, load from memory with acquire semantics, store from memory with release semantics. Okay. I swear, if this is a CPU bug in the end... Okay, so it's the release... Oh, no. It is what I sent on my email. It is what I sent on my email. It's what I sent on my email. Look, no, hold on. They are two operations. It's literally... It's this. It is this. It's an LD set al. It's literally this. This is... Okay, that makes the M1 the first ARM64 CPU where this actually reproduces. Here's the thing. It's an acquire and a release. An acquire and a release is not a full memory barrier. An acquire and the release is not a full memory barrier because if you do acquire and then release, the only guarantee here is that anything in between, the acquire cannot move after anything in here, the release cannot move above anything in there. However, anything that's before, right? Like, it's two separate operations there. So, and this is the load, right? And this is the store. So what you actually need is for this store. And hold on. Let me reread my own thing because it has to be the same thing. Yes, right. Yes, so there's no ordering within the acquire and primary operations, within the stories and subsequent memory operations. So, hold on. It has to be this. I already went through this. Hold on. I need a second to process this again. Load acquire and primary memory stories and subsequent memory operations. Right, so the release just guarantees that it happens after that. So this is legal. And the acquire, so this is still legal. And there's no ordering between these things. Yes, I'm gonna need litmus tests for this. Am I not? I did check the chicken bits when I did the M2, I think, or something like that, and we did add some, but I doubt they changed them since then. Yeah, so that problem is that AB aren't ordered with respect to each other, so AC. But that's not quite what's causing the problem here. The problem here is that the actual, unless there's a different issue, but I think the problem here is that the actual, like, pending store, so the release is happening before A, and that shouldn't happen. So something else might be relying on this being a full barrier. But I don't think the TTY layer is. Either way, the API is definitely, like, this applies to that for starters. That's for sure. However, I still haven't figured out why this breaks this particular case. Because that does look like it creates ordering here. Okay. Yes, the bug is very easily reproducible. Actually, I can just show you. Just make sure it reproduces with this and try a write memory barrier there. Yeah, see, it hangs. So it's reproducible. So if I just do a write memory barrier here, if this works, then either something is relying on there being a barrier here other than that bit, or I don't understand what the ordering guarantees are, or it's a CPU bug. Yeah, that one liner scares me. Yeah, it's just like build everything, put together all the images, and run it on the hypervisor, and yeah. I built it earlier during the stream, so. Oh, it still hangs. Interesting. So it's not that. Wait, is this the right file? Yes. What is that compiling to now? DMB ISHST. What about that? Still fails. But we said memory barriers do fix it, right? I have a suspicion. That might actually make this a CPU bug if it's what I think it is. Though I'll have to write a litmus test to prove to myself that that's really it. Yeah, that works now. I have a suspicion. And that would make this a CPU bug. Hear me out. Maybe they have an optimization where LD set out doesn't actually issue a write if the value written is not modified, but then it's also not issuing an ordering barrier. Which is why a write memory barrier doesn't work, because it's a read only at that point. That means that both that function is broken in the kernel because it doesn't create the ordering it should, as I said, and this is actually a CPU bug. I'm going to tweet that. I need to write an Linux test because this isn't super. Hold on. What's the story leaves talk about storing the same? Okay. Okay, hold on. Where is that? Okay. Okay. Barrier instructions order prior memory effects before subsequent memory effects generated by the same observer. A read or write is barrier ordered before a read or a write from the same observer if and only if write 1 appears in program order before write 2 and any of the utilities of it before if only before and any of the following cases apply. So the ordering we're trying to create here is between the write and the test of a bit. So it's a write to read dependency. Before an atomic with both of semantics appears in program order. Okay, so that claims that it creates order between those two things, but it doesn't say the instruction itself. Okay, so that write so the write should be ordered before that write. No, it is what it's not a CPU bug. It is what I said. This is what's happening. The atomic instruction is not actually atomic as far as the memory model is concerned. Here we have a store. Here we have a load. Here we have a store. What's actually happening is this. So the atomic bit gets checked. It says, the work is already pending. Then the work is getting queued. Sorry, not queued. The pointer is being advanced, and then that bit set is actually getting committed. However, what can happen is the other CPU in between here goes and says, I'm going to write and clear that pending bit. And then do the work. And that happens before the store. And the thing is, there is ordering between the store and the release. However, ooh, this is tricky. The barriers here don't mean anything because that's local to this, which is not actually what we want. This one matters, the full barrier there. That just means that these two can't be reordered, but that's fine. That doesn't help anything. So the only question is whether that clear pending implies any ordering with the atomic store here. You would think it does. However, I'm not so sure. I think I need a litmus test for this. In other words, I think atomic instructions just guarantee that the operations on the memory follow the requirements of atomic instructions. They don't enforce program ordering. So it's possible for this clear pending to use the value from this release store, but not actually introduce an ordering requirement with that release. I think. Because obviously this can't actually run before the store, because then there's a reset the value, and this is clearly returning false. So what are the requirements on atomics? I think I get it. The thing is, both CPUs' views don't have to be the same. I think. Read one is a write. Acquire PCs. No, that's not it. So okay, ordering relations. Basic definitions. Hold on. What's the from the same observer? So they are, these two are ordered from the same observer. And then we have an ordering between store and release. I need 2 columns. Anyway, these barriers don't mean anything. Set work data is presumably a simple store. Atomic long set. Okay, it just sets. What's atomic long set? Probably just a store. It sets inline PWQ. How do I find that? It's right before that. Must bin and lock IRQ. These are the barriers. It's just a store. Yeah, it's just a regular store. This because stores are atomic on ARM. So there is the atomics as seen from this side have to be ordered. Now we know that was set, so that means this has to happen before the store. And then the store here, what about the release? Prior memory effects with 13 memory effects generated by the same server. So if the right is has release semantics, then the first one is barrier ordered before. So that would imply that this this store is at the very least in here somewhere. Uh, Atomic ordered before reader, right? Assume the same as server, if only if already one in principle before it too. Acquire load store restore. No, this is a TTY issue still, except it's not the TTY issue anymore. It's like the kernel is totally broken, or the CPU has a bug. But see, the question about how atomics ordered versus other operations. Uh, hold on. So what stops atomics from being not atomic with other rights? So this just says that reads have to be ordered after atomic rights. What stops a write from corrupting an atomic increment? Are writes just not atomic on ARM64? I said I checked the chicken bits like way after this was released. Um, I'm gonna have to start writing litmus tests, but maybe writes aren't atomic on ARM64. Would that actually cause problems with other use cases of atomics? No, because who cares if the write happens up? It's just as if it happened afterwards. It's purely a memory ordering issue. Wait, is it? No, it isn't. Because then we can have it was set, it got cleared, and it gets set again by a single instruction, and yet it returns that it was already set, which is not what you expect. Nah, I don't think it's the MMU settings. Okay, hold on. Atomic. Is there a way to test this without Mini? You mean without the hypervisor? This happens without the hypervisor. It's nice that it still happens with the hypervisor, because otherwise debugging is more annoying. Uh, I think writes aren't atomic. Not against these instructions. Yeah, full system barrier does fix it. Okay, I need to write a litmus test for this, and I'm going to okay, hold on. I need another tweet update because people love those. Hold on, let me just do a thing. Okay. For tomorrow now, I can't go to sleep. Yeah. I need to start writing litmus tests. How I did this before last time I ran that. Do I still have that? Where was I running this? I still have to install this here. I don't think I guess I was running this on some random Asahi machine I have. Or was it the online thing? Oh, that was the online one, yeah. ARM64. Yeah, we can use the online thing. So here's the one that I had previously. That didn't work. Hold on. Has this changed? Move one, set, hold on, it sets. Alright, I saw how this worked. Wait, this used to fail. Unless I... Yeah, I have a Raspberry Pi lying around, but hold on, this... This used to fail, I'm pretty sure. Has the definition been updated? Oh! Something changed. This used to be positive, and then it changed. What did they change? That's... Yeah, well, if they patched the spec, Apple already abused it. What did they change? Let's put it here. Actually, put it here. That's very few changes. Okay, let's read that log. This change is a relaxation. That doesn't make sense because a relaxation would not fix the problem. They changed something else here. No, it's not just the pick thing. It's not the tag. Or maybe it's just a bug in Herd 7? What changes there? CACA and RF. I wish I actually understood what this is what this is doing, but is it just that pick thing? Okay, that still fails. No, it doesn't. Sorry, it does have the. I don't actually know what those things are, but hold on. RF. Okay. Wait. RF. Yeah. So CACA is what doesn't happen with 07. It could be a Herd 7 bug. or just something else that changed and like these specs are wrong. I'm not so sure about this thing there. Intrinsic. Yeah. Okay. So let's say that something is wrong in V7. Stick with that, and now see if what I no, I forgot. How do you set initial values in this? X1, X, X3, Y. Those are the addresses. Yeah. I don't know if you can set initial states here. I could just need to clear though, but hold on. Litmus test. ARM. Where's the language? I think there was a better. No, this is not what I want. How do I? What's the name of that thing? Okay. Not the model. There's the language for the tests. Okay. Uh, hold on. I know there was a nice explanation for this somewhere. Uh, extended version. Where's the explanation for this? Okay, initialization says okay. How do I specify otherwise? Okay. Oh, yes, that's how it works. So you have to put that in there. Where am I? Where's the here? So let's initialize x to 1. We do an LD set out in the left-hand side, setting it to 1. X1 is X, there's no Y, don't need any Y, there's a single value involved here. And the arguments for that are WSDT, XN. Yeah. So this returns that in X2, and we're not doing any loads after that. And then the other side is just going to do str. And so the question is, can this yield a result where... Let me just get rid of the test section and run it, see what all the outcomes are. Doesn't show. So either... Let's see, what I'm actually testing for is that... Oh, I need to set the final value though for this. Right. So the answer should be that hold on, let me read the docs again for that. Hold on. Let me just duplicate this, make sure I understand it. Litmus tests are confusing. Yeah, states 4, 0, 4, 1, 1, yeah. Yeah, so we're looking for one where both this returned 1, saying it was... So x2 is 1, and also x is 1. Ah, okay, it only likes registers for that. So I guess we need to load afterwards. Uh, uh, uh. Condition exists. I know, what I want is that x3 is 0. You know, hold on, no. The store is in the middle, so this means this has to return that it was already 1, and it also has to be 1. Oh, but then no, but we need a barrier here after that. How do I make sure that? Hmm. I need to introduce ordering between these two things somehow. I'm not sure how to do that. Does that even make sense in a litmus test? I guess I can just load on the right side. So what we're looking for is that x3 on the right side is 1, which means that the atomic executed, quote, after the store. And yet, the left side claims it was already 1, which means it executed before the store. Exists. And if I do ld clear al or something like that, which is actually atomic. No, it does exist still. Why? Do I need a barrier here? Oh yeah, no, it does exist. Yeah, -4. Okay, yeah, so that does work. Yeah, okay, so those are negative. And if I store, wait, that's a 0 to x1. No, it's still negative. Sorry. Okay, so this is not reproducing it. Let's try some older versions, see if anything interesting happened. Nope. So now I guess I have to run this on real hardware. No, this isn't exactly the test I'm trying to do. What I'm really trying to do is a store on the left side. Let's do the full test. Oh, is that done? Yeah. Okay, so we do a store to x8 on that side. And then and we load that on this side. And then the question is, x2 was 1, which means it was already queued, and x3 is 0, which means it didn't get written. Positive. What about 07? That doesn't change anything. Now there are barriers on this side. Those fix it, according to 7. What about 6? Still, okay. I was kind of expecting, yeah, to end up in some assembler stuff today, to be honest. Also, those are strictly speaking not lows in stores. They were like, they're actually store, what it's actually doing is a SMP store release. Which is a what? They were inner shareable, but I think that shouldn't actually change anything. Hold on. Yes, the MBI is HST and yeah. Where's the atomic stuff here? Instructions that are reviewers and stores. Where's that? STLR. So this is store release, and then in the actual here it does a lot of acquires. So it's STLR and LD LR. LD. Hmm. Where is that? LDAR. Yeah, it doesn't change anything. I guess we need to write this in Oh, so this isn't necessary anymore. Yeah, I'm gonna have to run this on real hardware. So Litmus 7, where is that? Is it GitHub or something? No, where is that? DIY 7. Yeah, that. There's tools for this that just does it. Probably not in the packages though. Yeah. Where's the code? No. There's the downloads. Install. Oh, hurt tools. Okay. Yeah. Oh, and this is written in OCaml. Of course it is. Can I just do that? Are there binaries for the releases? No. This one's the real thing. It runs on real hardware. Hertul 7 Git is in AUR. I might as well do it this way though. It's easier than AUR to be honest. Let's just let it do that. Okay, how do I use it? Just run it. Yep, that's easy enough. Okay. Asahi, let me just make a thing there. Let's put that in there. I think that's that. Let's see if it runs. Yeah, let's There's gonna be some bin somewhere. Yeah. Host name? Right. Which package is that in? Is this host name? No. What is that these days with like hostname CTL and all that? Why do I not have that? init details? You should just pre-install that. Yes, Masari is Apple Silicon. Oh, right. I need to... How do I do that? Yeah. How do I set the C flags? Is it just... Is there like a proper way of doing that, or do I just need to... Is it mark? Uh... you can do ARM v8 v3. Oh, because it wants... Yeah, it's unknown Linux, and this wants... Linux to see, how do I do that? Cross... On... Is it just dash GCC? Yeah. Oh, what? Is it just ignoring me? Oh, does it have to set it afterwards? Ah, okay, there we go. Execution failed. Oh, so why are there different types here? Hold on. Oh, these are all 64 bits. Why is it saying something about... Intent N64T. What does that even mean? Come on, Google. Okay, can I just do something trivial? Just to make sure that... Okay, so that doesn't fail. So why... Why would execution fail? Is it this is the type thing? Hold on. What is making it fail? Is it just LDAR? Wait, which version does that need? No, but you have that anyway. What? Yeah, if it like it's failing to run, right? And xHCI is initialized here. Sig bus. Is it because of that? I think I know. I think I know why. Yeah, I know why. It's because I need to tell it that these are 64 bits somehow. It's trying to do like unaligned atomics, and that doesn't work. Maybe I can find some examples. No, there's none of them there. Are there any in the website that might show that? Or do I need to tell it? Because these are all W's, right? Must summon. Is there a way of a word size? No, that's not what I wanted to do. I mean, I can just move everything to using 32-bit things anyway. So who cares? Because why not? Okay, I think it worked. Okay, so that's not it. It's all showing up as negative. But I need to also check that the I also need to check that yeah, you're right. I should be doing this at 64 bits anyway, just in case it's a bug on the CPU and it matters. How do I do that? Uh, no, that's not what I want. Compile Litmus. Stride. Is that it? Stride? No. Yeah, you think of a characteristic of a variable, but how do we set that? Where is the language specified anyway? There's a spec for this somewhere. Hold on. Identifiers. Identifiers on the values. Isn't this the model format? Yeah, this is the model definition. That's not what I want. What's the test definition? Line 64. Okay. Where is that? Oh no, that's. Oh, you lit. Fine. That's how it works. Okay, no positives. Um. But this is not the exact test I'm needing. So what I need to figure out is whether ah. So the first one thinks it doesn't have to queue it again. The right side thinks there's no more data, and well, it should be sufficient. Um, so just out of curiosity, is that a thing? No, still no positives for that. So either that runs before and then it gets cleared, or that runs before and then it was 0, but never ends up at 1 again. It works now. It's not an OCaml issue. Um, so where is the problem then? Are you back to oh, well, the cores treated similarly. That's a good point. Let's put this on the P cores. Though, I mean, it should still fail at some point if it's running on all the cores. Could it be that X and Y are sharing a cache line or something? Hmm. Sharing cache lines. The thing is, I'm not sure if it actually does that. I don't know if that does anything. Doesn't look like it. I'm not so sure this would do much. Hey, out of curiosity, the one that this one that was hypothetical, but I don't think I ever tried it on real hardware. Let me do that just because. Okay, no, so that also doesn't repro. So now what? Is it something else with work queues? User space versus kernel space shouldn't actually matter. Okay, hold on. Let me do a bit of more print debugging here. So, because I don't even know, I haven't even checked that work queue actually ends up calling that. Hold on, let's see what the buffer thing is doing. Oh yeah, it does do that. Yeah, it's just flushed away disk. Maybe it is a different race. TTY.h. It's in TTY buffer. Okay, they're just ints. So let's try. Do that. Otherwise it continues if it next to break. Okay, just to make sure we didn't break anything. Yeah. BRB, all that compiles. Okay. Yes, that did fail. And let's also print the pushing stuff. Oh, is it just because of Right. It doesn't actually. Do I need to chain load? I think I might be okay without for this one. It is a bit old, but I don't think we've changed anything major in the hypervisor in a while. See if I can get away with that. Yeah, I think it can get away with it. Yeah, it looks like it. Okay, the prints are making it work, unfortunately. Oh, well, that's interesting. Look, like write, read. Although that doesn't guarantee order. Yeah. Because those prints come later anyway. That just means that it's executing here. And then it writes another one and queues it again. Yeah, so that's what you would expect. Oh, there's a Litmus 7. That might be useful, but hold on. Okay, so they're failed. Let's do a print on the failed to queue path. Not tail buff, tail used. Yep. So look at that. It failed to queue 1210, but it only read 1024. So clearly, yeah, this is the problem. Also, look, it's like 1 microsecond difference there. That's also telling us how close we have the race here. Yeah, but adding that print makes it not fail. So basically never fails to queue in that case. Because it only fails to queue when the stuff comes in really quickly one after the other. And in that case, the thing slows it down enough that it doesn't happen. So if I put a memory barrier just before that, shouldn't actually do anything. Yeah, that fixes that. Looks like it. But why? Is it because there's no barrier between both queue commits? Qworks? What if I do it like this? Maybe it's the interaction of the of both of them. Hold on, let me try both barriers on both ends and then just the right memory barrier. I mean, this is a TTY layer, but like from what I can see in the code and the log I just got, this sounds like it's a workqueue problem. Yeah, that fails. Interesting. So a barrier before. Yes, it's good when it queues twice in a row. Let's try a right memory barrier. Let's try both of them. Yeah, MB should be ISBS IS, I think. Not ISB, sorry, DMB. MB should be that. DMB ISH and WMB should be DSB ISH. Okay, that doesn't fail. So a right memory barrier is sufficient. Hmm? Did it just die? Oh, that might be the bug, like on this side, because this kernel also has the same problem, right? So, I don't feel like working around it right now. Yeah, that right memory barrier before it fixes it. But that doesn't really make a lot of sense because um oh. I have an idea. What if the problem is What is that? The local, what is that thing? SMP processor ID. My hostname is Raider, but I'm SSH1021 Mac because that's where all my kernels are. Okay, that doesn't reproduce with that barrier. No, it's not a print K problem. This is a race condition in the TTY layer that is starting to. It was sounding like a related to some of the atomics not being implemented properly, which I do know they aren't because I did have that Litmus test, but I'm not so sure again about exactly what the problem is. Okay, that fails. Looks like they are mostly the same CPU. Yeah, they're mostly the same CPU, yeah. I think that's going to break it. I'd rather make it not reproduce again, but just to see. I want to see if the two things are executing on the same CPU or not on the queuing side. The CPUs are kind of random. They change all the time anyway. Yeah, that makes it not reproduce. And you can see how it's moving between some CPUs, right? And in that case, it failed to queue from the same CPU, so I don't think that's the problem. Interestingly, then it did read it afterwards. I might need to take a break to grab some food. Uh, okay, so write memory barrier before does fix it, I think. Yep. And it's always when they step right on each other, right? Like, look at the timestamps there. So it really is a race. So let me just move that right memory barrier around a little bit to see. Can I read substitute for a white memory barrier? I don't think so. Uh, yeah, okay, so that fixes it at the top. What about in between? If a write is not posted, will you not force it to be committed? That's for MMIO. This is regular memory. It doesn't work like that. Okay, so it looks like that doesn't reproduce with a memory barrier there, which is fine. Look at some of the non-queue cases. Yeah, so it just fails to queue, but it then still always reads that. So what about at the end? Yeah, that fails. So barrier at the end doesn't do anything. Oh, look, it even printed after that this time. So it has to be a work queue issue. So in qwork, So back to the ordering between this and this. You think it would be valid in writing a small test thread just test the work queues? I mean, this test case that I have is giving you the right results, so I don't need to write another test case. Tool ID set work data. Isn't it just the ordering between this and the previous thing? But we had the acquire and release semantics stuff. This should be using release semantics for the right. Uh, I still think there has to be something about like that story with the acquire and release semantics not being equal to a full barrier. So it's a DMB SHST and then a SHD, that's right. In between that, there's just a store. And in the TTY, we have push. It's LDUR for, oh, hold on, sorry, STLR for the push, and LDisk. First LDisk is using an LDAR, yeah. Oh yeah, those were 32 bits, right? Yeah. No, they are. Oh yeah, the second one is 32 bits. Yeah, so I guess that should be. Um, the flags is long. So it's two different things. Oh, that's an interesting difference here. These RW0 then. So int. Positive 0. No. What about the other? This if this returns it's not queued and x8 equals 0. Yeah, 0. No, that doesn't. Oh wait. Wrong. Wrong thing. Why? Oh, sorry, not x8. X3. X9 is what I wanted there. Oh, wait, hold on. Positive? So it does not queue and x9 is 0. That's... well, if this all runs first, that would be 0. That's fine. No. Wait, isn't this the bug? Hold on. No, it still does that. I think I'm doing something wrong here. I hope. So I assume work is already pending. Then back to x3. Hold on. Just undo a bit. Okay, no positives on that one. Oh, there's no Z. I don't care about that. Hold on, hold on. No, hold on. What? I think make it not print the CPU info. I'm not interested in that. I just do. That's better. So what did I have before when that happened? W3, X8, X8. Was it because I changed the type here to 32? No. Why does it say X0 has different types? 40 and X. Oh wait, why am I using? Oh, I guess it's yeah. Let's just kind of make sure this isn't getting confused by this. X2 has different types. Int and ARM64T. Does that work? I don't know about that, but I was expecting on the X9. Yeah, but then that just means that that's fine. That's not a fail condition. If X9 is 1, yeah. Yeah, no, I just screwed it up. Yeah, I just had it wrong. Okay, so let's try to reframe how this works. What we're really looking for is that P0 is about to queue something. P1 is already processing, so it already loaded X8. I really just want to make these two separate lines at this point. Doesn't matter otherwise. So what's going on in the second CPU is we first load the value from X1. Sorry, from X8, which is the thing. So we need to make sure that we get W9. So it's not queued. We got the old value, and so let's say this already decided that it's pending. So it's going to it's LDAR. No, this is the same thing, right? LDAR W9X8. Uh, LDAR. It never gets queued again, which means X2 is 1, which means it doesn't queue it again. Yeah, this should be after the store. So this was kind of right the way I had it before, yeah. So I'm looking for LDR W3. Oh, what I'm looking for is 0 there, right? Yeah. Does this change anything? No. So according to this, it can never happen. Just run it a bit more just in case. It's not doing anything. Hmm. That's slower than I expected. Oh, the number of runs is like much larger. Oh, interesting. Using that number is like more. Yeah, that helps a little bit with the numbers or variation. Yeah, it's. I think this is correct as far as reproducing the issue. It's not triggering. So what gives? Failed to queue 1210. What if I get rid of the barriers? Does that make it? Yeah, no. So the barriers are necessary. Hold on a second. First of all, this isn't a pinning thing, right? Let me just see what CPUs this is actually running on. Looks like a bunch of them, which is reasonable. I'm just gonna make some noise. Yeah, it's too long. Yeah, still no positives. If I got rid of that barrier, still no. Yeah, so this one is necessary. Yeah. Oh, just 4 though. Also, there should be LDAR there. Still needs the barrier though, I think, going with that. Yep. Hmm. Do I happen to know the extent of core site support on this chip? Definitely nothing over JTAG because all that's locked out. There probably is some tracing stuff, but I don't know. I know there's a core site register set, but I don't know if we can turn that on. I think we need to take a break, get some food. 1 sec. Hmm. Unless it's something else in here that... Hold on. Process won't work. Hold on. Worker. Yeah, so it clears pending and then runs the work, which makes sense. Instead of initializing this to 1, let's try initializing it to 0 and then doing that twice. Oh. Wait a second. Hold on a second. What am I doing wrong? This is fading too much. It should unconditionally set x1. Oh, but then this can't run until after that is set. Hmm. The thing is, this isn't exactly what the kernel is doing, which is it's a little bit tricky. Can I have branches in Litmus tests? I'm not sure if I can do that. So in this case, it's like the first one. So this has to run before, then that sets it to 1, and the second one is expecting a 1. Wait, why is that never true? Oh, because it's 3, sorry. It's a set. So the second one is setting, yeah. Right, so 3, 2, which is when both of them ran like that. So this sets, sorry, sets, I'm confusing myself. Set 1, set 2. For actually, let's just say it starts at 0, and then here it sets bit 1, then it sets bit 2. Here it puts another 0 back. Actually, let's say it starts at 1, 2, 4. stores, and then the second one we are expecting we get a 0 or something in x2 and a 0 in x3. So the second case there, and x3 is 1, which means this might. Oh, this might be it. Hold on. This starts at 1. I set bit 2. x3 equals 1. That means that because this is resetting that to 0. That means that hasn't run yet. So now it's 3. We store the value. And then we set bit 4. So here we expect a 1. Here we expect a 3, which means this still hasn't run yet, because it would have cleared it otherwise. And then this guy has to run afterwards. And yet does not get that value. Oh, but not positive. Wait, what? x2 or 3. Okay, so I don't have that case. So what about the other one? So this one says that means that it ran at the beginning of everything, which is fine. And what about this one? This one says that it ran in the middle. So it would have run here, I guess, which is still fine. That's actually the case I'm trying to test now. And then I expect that to be a 0, yeah. So it still doesn't answer anything. Yes, that is the TTY you should be thinking of, yes. But also serial ports and everything else. Would it be a pain to restate the problem? Just exactly what we're seeing that we shouldn't be. I mean, in the Litmus test, nothing. But here, the problem is that this yeah, I'm like tired. So TTY flip buffer push does a flip buffer commit. which writes the commit field, then tries to queue some work. If some work is already queued, then it doesn't queue any more work because it should already be able to handle that. So what I'm seeing is that, so this is always queuing 2 packets, like in close succession, and this always fails when they're really close in time. So what's happening is it's queuing 1 packet, the work queue is starting to process that packet, and then it tries to queue the second packet. However, the work is already in the queue somehow. But it shouldn't be, because look, it just printed this, which means the work was already running. Of course, there's some, and by the time it's running, it shouldn't be in the queue. Now, of course, there's some, the test could have run before the read, so that's not guaranteed. But the point is that it didn't run the work again after that. So the work was queued once. It saw the buffer at 1024. Then it added stuff to the buffer, tried to queue the work. It was already in the queue, and the work being in the queue pending means that it hasn't started running yet. So, like, this test happened before this line somehow. But then the work only saw the previous value of commit. And then there was no more runs. So the work ran, it only saw the previous value of commit. And this, which is queuing the new value of commit, saw that the work hadn't started running yet. And so in work queue, the part that does qwork uses a test and set bit, which is that ld set al. And if it was not already set, then it queues the work. So in this case, it was already set when it did this. And meanwhile, the other side of the work queue stuff where am I? And the other side of the work queue stuff is just doing an atomic write, which is a simple write, and with 2 barriers around it. And so that should be the same as this litmus test. Set work data is this store. Those are the barriers around it. This is the actual work trying to read the updated value. And we test for 0, which is the old one. Unless, yeah. We could do 1 and 2 here just to make it more interesting. So we do 1 and 2, and then we test for, yeah, let's see if I can do one of those. Let's see what that does. And so the failure case would be that the 1 gets written, so this sees not a 2. Yeah, so it needs the barrier. So this sees not a 2, so it doesn't see the final state. But the first one, x3, so that should see a 1, which means it ran before. Actually, no, we can do a 0. Say that it runs. Yeah, one before, and then the second one sees a 3, which means the other one was already pending. And yeah, I can't reproduce that here. Though this is having suspiciously few hits. But still, I'm not finding it. So basically, the problem is it possible for this function to return the thing that I think it runs afterwards to do a load release, so load acquire, and meanwhile the other side ran this. It returned 1, which means it was pending, which means it like that happened before this set work data call. And yet the stuff running after this is not seeing memory writes before this. That's as simply as I can put it. And test and set bit is still broken because it claims to be a full memory barrier, which it isn't. However, I still don't see how it fails in this particular case. And yes, there are some branch ops. But But the thing is, even if there are branch ops, you'd say it would speculate and load from the cache, but okay, I'm gonna get some dinner, and I guess I'll have to look this at some other time. But I also need to ping. I might just write an email to the mailing list and see if the ARM people have any ideas. So yeah, I think I'm gonna stop here for now. I might be back later after I get some food and keep trying stuff and see what happens. So, see you all later. Now I'm wondering if I should really like try to fix this as the next thing I do, or just like work around it, let the email thread like go its way while I work on other stuff, because I could spend weeks on this if it's as weird as it's starting to look. Anyway, all right. Thanks for coming, and we'll see how deep this particular rabbit hole goes. All right. See you.